All right, let's get this math party started. Tonight we've got two lessons we're going to focus on. The first one, to lead things off, is we're going to focus on adding and subtracting rational expressions, which basically just means we're going to focus on adding and subtracting fractions. Rational expressions is a fancy way of saying fractions with a variable or two thrown in there. And before we dive into this one right here, actually I want to introduce you to maybe a little simpler one and just kind of we're going back to basics here. And what if let's say we want to take 3/4 and we want to add 2/5. So the name of the game when we're adding or subtracting is to create a common denominator. And in this case, when I consider a 4 and a 5, I'm picturing a common denominator of 20. Now in order to create that, I've got to multiply this fraction by 5/5, and the key is we're multiplying the top by the same number as I multiply the bottom. And then we're going to multiply the other fraction by 4/4. And what that does is that makes the first fraction 15/20, which is certainly equivalent to 3/4. And it makes the second fraction 8/20, which is certainly equivalent to 2/5. And now I can add them together for a total of 23/20. And then we just check and ask ourselves, can we reduce 23/20 and say, nope, that's the best we could do. That's the most simplified answer. So let's see if we can apply that same concept here to one that's slightly more challenging with the x. Now in this particular case, I think my common denominator that I want to see happen is an 8x. And in order to make that happen, I'm going to multiply the first fraction by x over x. And the second fraction by, well, it's just a 1/1, and certainly you don't have to show that, but I'm just emphasizing that I'm multiplying it by something, I guess. And that first numerator is 5x. The second one stays as a 3. Now that we got those common denominators, we'll combine them together to make one big fraction, and there's no GCF to worry about or simplify, so boom, there's our final answer. Now I do kind of have an outline in a four-step plan for you, but I want to get a couple more examples under our belt, and then we can kind of go talk about the plan and see if after we've got a couple underneath our belt, we'll see if the plan makes more sense. But on this first fraction, I want to get the denominator factored first. That's a key thing we always look for. If there's an opportunity to factor, we want to jump on it. And once it's completely factored, then you can kind of create a vision for what you want your common denominator to be, which in this case is going to be 4 times the quantity x plus 3. So the first fraction doesn't need to change. And to emphasize that, I'm going to multiply it by 1. However, the second fraction needs to get multiplied by 4/4. So my first numerator remains a 2. The second numerator becomes a 28. And now I can combine two fractions into one fraction, and that becomes a 30/4 quantity x plus 3. And actually here I do have an opportunity to reduce. One of the things we are going to stress is that we don't want to worry about simplifying or reducing until we get to the end. We can divide both of these by 2, and it reduces real nice. So we got 15/2 quantity x plus 3, and that is our most simplified final fraction. So now we've gone through a couple, we'll try to write out our steps. And the first step I always want to talk about is, again, we said if the opportunity is there, we want to factor these denominators. And that's super important because without factoring them, it's really hard to create a vision for what your common denominator is going to need to be. And then beneath that, we could make a note on the domain. We'll make a note on the domain and basically remind ourselves, we're going to say the denominator is not allowed to equal 0. And we haven't done that yet, but we're going to try to do that in the next example. And then from there, we can create that common denominator that we now have a vision for. We're going to combine the two fractions into one fraction. And here's the key. I don't want to worry about step 4 until after I've done step 3. So once we have combined them into one fraction, now we can consider the idea of simplifying if possible. And a lot of times it won't be, but we'll be on our toes ready if it's there. So here we go. And when I looked at these denominators, there's no factoring to be done. There's no GCF. There's no difference of two squares. There's no trinomials or anything like that to worry about. So once we've confirmed that, I want to talk about the domain. And with reference to the domain, I'm going to say that the domain is all real numbers except for x is not allowed to equal -2. And the reason is if I substitute a -2, then a -2 plus a 2 would produce 0, and we're not allowed to divide by 0. At the same time, x is not allowed to equal a +5, And that's because of what's happening here. 5 minus 5 would create a 0, and that's no good either. So we just make a little note of this, and this is going to pay off towards the end of the video just to create that habit. The common denominator that I'm visualizing here is a combination of x plus 2 times x minus 5. And this is kind of a safety go-to strategy. When in doubt, just multiply the two denominators you have together, and the product of the two will always be an adequate common denominator. It may not always be the least common denominator, but it'll create a common denominator nonetheless. And that means the first one needs to get multiplied by x minus 5 over x minus 5, therefore creating 7x minus 35. And little trick here, I'm going to change my minus sign to a plus sign, which means I negate the 4. And then I multiply the top and bottom by x plus 2. And as I distribute that negative 4 to both the x and the 2, I get negative 4x minus 8. And I think that's a real safe way to handle that negative sign so that we don't forget to distribute it. From there, I can combine the two fractions into one fraction. I want to do that as fast as I can. I'm not worried about simplifying it. I just want to combine two fractions into one fraction. Combining like terms, 7x minus 4x is 3x, and negative 35 minus 8 is negative 43. And at this point, there's no GCF, therefore there's no simplifying to worry about, and that's my final answer. Alright, one more example just to be safe. And there's no factoring to be done with x plus 5, but by golly, we've got a trinomial over here that can be factored. So I'm going to jump on that. So the first fraction remains 3 divided by the quantity x plus 5. And the second denominator, I'm thinking x plus 5 and x plus 2. And now that we've got it factored completely, let's just make a quick note about the domain. Our domain is all real numbers, except x cannot equal negative 5 and x cannot equal negative 2. Okay? Alright. Now, what are we going to do? Let's multiply the first fraction by x plus 2 over x plus 2. And we'll multiply the second one by 1 over 1. And let's see. The first numerator is 3x plus 6. And certainly, if you're feeling real strong here, you can buzz ahead and try to finish this one on your own. And then the second one's going to stay x. It's going to stay x plus 5 and x plus 2. And now we're going to combine, this is a pivotal moment right here, we're going to combine two fractions into one fraction. And that one denominator, of course, is the common denominator. And if I combine the 3x and the 1x, it'll give me 4x plus 6. Now I got a little excited here because I did see a GCF in the numerator, so I factored it out. However, it did not create any like terms that could be canceled or divided out. So I just wrapped it up right there and said, there's my final answer. So notice what we've seen in these examples so far is we're trying to either add or subtract and basically combine two fractions into one fraction, and make no doubt about it, our final answer so far has always been a fraction with a slightly restricted domain. Okay, so we're at our halfway point with the lesson, and we're going to kind of upgrade to a little more challenging topic, and now the new title is Solving Equations with Rational Expressions. And so the big key word here now is equations. And you do see the equal sign all of a sudden, and this is something that we have not seen yet tonight. There has been no equal sign. So basically now our job is solve for x, and at the end of the day, our final answer is not going to be a fraction like it's been earlier. It's going to be like x equals 2 or x equals negative 6 or something along those lines. And just to kind of set the table, again, let's rewind and maybe go back to basics here real quick. Consider this example. What if I said 3/4 plus x over 4, and what if I told you that equals 5/4? Okay? Could you just sit there without doing any fancy math and tell me what x has to be? I think you'd all agree that, let's see, this x right here has to be a 2, right? Because 3 plus 2 equals 5, and it falls into place because you've already got common denominators. So as long as you've got common denominators, you can basically ignore the denominators and just worry about solving the numerators. You know, subtract 3 from 5 and you get x equals 2. So without anything fancy, just using common sense, you're good to go. Now how about this? What if I made it slightly more complicated and I gave you a rational expression like this, and I said we're going to add it to x over x plus 2, and we set it equal to 8 over x plus 2. Could you still solve this one just by sitting there and not doing any fancy math? Like literally not even lifting your pencil, and you solve this one. You're thinking, here's the good news. Look at this. You've already got the same denominator across the board, so you're thinking 3 plus something equals 8. That something must be a what? Yeah, that x has got to be a 5, and so forth. So our goal tonight is to create a common denominator, and once we do create that common denominator, just basically ignore it and solve the numerators. That's our big goal. So let's take a look at this, and presto, look at what we've got. Common denominators across the board. And what I'm picturing is like one of those fruit machines in the casino. You know, pull the lever and boom, boom, boom. We got cherries across the board right here. So what that allows us to do is you could literally cross them off, ignore them, and say to yourself, by golly, 15 plus 7x has to equal negative 6. 7x has got to equal negative 21 if I subtract the 15 over. And last but not least, x equals negative 3. And that's a keeper. In other words, check this out. I'm going to say x equals negative 3 is okay because x is not allowed to equal 6. I almost said negative 6. X is not allowed to equal 6. Why did I say x is not allowed to equal 6? Because I was looking at these denominators, reminding myself that there was a restricted domain. So x equals negative 3 is the solution. We don't have to reject it. It's okay. In our second example, the big buzzkill is this. I do not currently, as it is written, have common denominators. Slight buzzkill. So the first thing, let's create a common denominator. I'm going to multiply this fraction by x over x, and I'm going to multiply this fraction by 7 over 7. First one stays as is. Second fraction is now x over 7x. And the last fraction is now 28 over 7x. Now that I've created those common denominators, bang, bang, drop them. And just worry about your numerators. We could say 3x plus x equals 28, which means 4x equals 28. And once we divide by 4, we get x equals 7. What do you think about 7? 7's okay, because why? Why is 7 okay? X is not allowed to equal 0 based off of the denominators I saw, and as long as it doesn't equal 0, we're good to go. 7's in the books. Keep them. Alright, we got another one cooking, very similar to the last one. So if you're feeling strong, this is a great time to test yourself and see if you can get especially the first step. See how you do on the first step on your own. And I see a 3x, I see a 6, I see a 2x. There's no factoring to be done. These are just simply monomials, so nothing to worry about there. And what is your vision for a common denominator? Maybe I'll make a little note here. My common denominator is going to be 6x. So that's my goal, is to try to create a 6x underneath each fraction. And in order to get that done, I'm going to multiply the first fraction by 2 over 2, the second one by x over x, and the last one by 3 over 3. It's going to give me numerators of 4x minus 5x equals 15. Again, we've created common denominators so we could wipe out the denominators and just equate the numerators together. So 4x minus 5x equals 15. Combine like terms. So I got negative 1x equals 15, and divide both sides by negative 1 to get x equals negative 15. Is this an acceptable answer? Is this an answer that we can accept and approve, or do we have to reject it? Well, I'm going to say that it's okay because the only restriction is that x is not allowed to equal 0. Again, looking at my denominators we had here. So negative 15 is the winner. In our next example here, we do have a little bit of factoring to be done. Again, in any time you see a binomial, we are on high alert, and we do have an opportunity to factor. So I'm going to pull out the GCF, and that's going to equal 8 over x minus 6. And now that you've got it factored, what vision do you have for your common denominator? What do you want it to be here? And I think we want it to be a product of 4 and x minus 6 across the board. So I'm going to set the table and get it ready for some action here. Multiply the first one by x minus 6 over x minus 6. This one's good to go, so we'll do 1 over 1. And the last one we'll multiply by 4 over 4. The first numerator, distribute the 3. 3x minus 18 minus 2x equals 32. We've got our common denominator, so we can just cross them off. That's my favorite part right there. And we can just simply say 3x minus 8 minus 2x equals 32. Combine like terms, so I'm really combining the 3x and the negative 2x to make 1x minus 8 equals 32. X equals 40. Is 40 okay? Yeah, it's okay. And it's okay, why? Because in this case, the only restriction is that x is not allowed to equal 6 because of this rascal right here. So x equals 40 is the solution, and there's no rejection. So now that we've got several examples under our belt, let's try to describe the process that we've used, this plan for success, so to speak. And again, we're going to analyze the denominators and factor, if possible. Again, especially look out for, if you got a binomial or trinomial, it's probably possible to factor it. And then we're going to make a note of the domain. Make a note of the domain. And that's going to be crucial because they love to throw problems on there where we end up rejecting something at the end. And then we're going to create our common denominator just like we did before. We're going to cancel all the denominators, just basically cross them off and just worry about your numerator, solve for x, and we're going to talk about checking our solutions at the end and the next example. Alright, is there any factoring that I could possibly do? Not on the first one, not on the second one, but good golly. Now, notice this. I'm not going to factor the numerator. I'm only going to worry about factoring the denominator because that's what I need to do in order to create my common denominator. The vision that I have is, let's see, I'm going to use the product of x minus 6 and x plus 2 as my common denominator. We're going to go ahead, set the table, get ready for some wild math action that's about to come down the pipe here. We'll multiply the first one by x plus 2 over x plus 2. Multiply the second one by x minus 6 over x minus 6. And the last one by simply 1 over 1 because we don't need it to change. Let's see. Let's distribute that 2 to make 2x plus 4. We'll distribute the 7, and we've got 7x minus 42. Just a FYI here, if this had been a minus sign, what I would have done is I would have changed it to a plus sign, negated the 7, and then distributed a negative 7. But it wasn't. And then we got 4x plus 2. Alright. I think we've done the hardest part, and we're in a position now where we can cross off these denominators, and we'll say 2x plus 4 plus 7x minus 42 equals 4x plus 2. What do you want to do next? Yeah, why don't we combine some like terms? 2x and 7x makes 9x. If we combine positive 4 and negative 42, that's negative 38. That's equal to 4x plus 2. What do we want to do? Subtract 4x from both sides and simultaneously add 38 to both sides. Divide by 5. X equals 8. Can we keep it? Can we keep it? I'll tell you what. I'm going to say 8's okay because the restrictions, we had two restrictions. X cannot equal 6 and x cannot equal negative 2, which means 8 gets approved. Take them to the bank. There we go. Now, as far as that check goes, here's what I got cooking. The easiest thing to do, and again, I think this is the quickest, easiest, is I'm going to store the 8. So on my calculator screen, I type in 8, store, x, hit enter, and then what I do is I type in everything on this side. And I use, of course, alpha F1 to get my fractions, alpha F1, hit enter, make a note of what you see, and then I type in this fraction exactly the way I see it with the x's, hit enter, and we got to see a match. We should be seeing a match. And as long as they match each other, then we can confirm that indeed 8 is the best correct answer.